Rule 6. Safe speed. Factors determining safe speed. For all vessels. State of visibility. Visibility is very important while considering the safe. Depending on the visibility, the vessel can adjust its speed for safety. Traffic density. Traffic density is also a factor because more the number of vessels, more our chances of collision, as more vessels will have the risk of collision. The probability of a collision increases with the density. Some areas containing many fishing vessels and small boats possess greater risk as they are often difficult to detect by radar or by sight. Maneuverability. The maneuverability of the vessel. To establish safe speed, we should know the distance the vessel will travel before coming to a full stop, for any normal loading condition or speed. When a vessel turns, its speed is drastically reduced. Many vessels will stop most quickly when put into a sharp turn. Stopping characteristics are also important in case of tug and tow, as the number of barges in tow makes a lot of difference. The maneuvering characteristics of larger vessels are required to be posted on the bridge. Background light. At night, the presence of background light. When shore lights are very bright, they make it difficult to spot targets on water. Thus, a reduction in speed gives enough time to make judgments. The backscatter of own lights also cause disturbance, especially when portholes are kept open and vision is hampered. Careful design of the light arrangement will minimize backscatter and reflection from the vessel itself. Sea state. State of weather condition and proximity of navigational hazards. The state of wind, sea, and current is to be taken into consideration. Advisable to go a controlled speed if too many navigational hazards are encountered. Draft. The relationship of draft with depth of water. In shallow water, it's better to have less speed as the vessel can be controlled, and if at all it runs around, the damage to the hull will be considerably less. Effects of squat and other shallow water effects shall be considered too. A deep-drafted vessel under the circumstances has to take special precautions in maintaining her speed. For vessels equipped with radar. Radar equipment. The characteristics, efficiency, and limitations of the radar equipment. The watchkeeper should understand the qualities and limitations thoroughly. The blind distances and the shadow sectors for the radars should be always known to the watchkeepers. The radars mostly used on board are the 3 cm X-band and 10 cm S-band. The X-band radars send out low power and higher pulse repetition rate frequencies. They have a limited range but more accurate. The S-band radars send out high power and low pulse repetition rate frequencies. They are able to look into and beyond weather. They have comparatively longer ranges. Range constraints. Constraints by radar range. Many radars function fully and good, but it may not detect vessels at some ranges. It is also possible that the radars may not be very good at low ranges or on higher ranges. Interferences. Effect of radar detection of interferences. Sea clutter and rain clutter cause a lot of interferences. Rain clutter is the reflection sent by raindrops back to the observer. Rain clutter sometimes obscures the entire region completely on the radar. This will not detect any vessel within that particular region. The clutter can be reduced by increasing the rain clutter control, but it will also remove weak targets. Sea clutter is a hazard, which affects mostly around the proximity of the vessel than rain clutter. This can also be reduced by increasing the clutter control button, but the effect is the same and it reduces the performance. Soot from the funnel forms the other source of interference. They can seriously impair the performance of the radar. Overlooking. Possibility of radar not detecting ice or other floating objects. The radar generally detects targets in 5 sweeps, and if a target fails to appear within that, then it will remove it. Thus, a small vessel, if it appears inconsistently, then the radar will not detect it. In case of ice, the electromagnetic waves are reflected by the ice in different directions, and they are lost, and the observer does not see the ice. Vessels detected. Number of vessels detected. Keep a track of each vessel in areas of high traffic density. It is an exhaustive task to assess the vessel with the most potential risk factor. However, this can be achieved easily with a radar tracking unit or an automatic radar plotting aid. While doing this, we should be careful when cautious of the risk factor set data as presented by the radar. The situation has to be assessed efficiently. Assessment of visibility. Radar can be also used to do an assessment of visibility in that particular area. This can be done by noting down the range of a target on the radar screen and then comparing it with the actual sighting. Since radar is not affected by poor visibility, it will give an almost exact assessment, unlike earlier days when visibility was estimated by guesswork, but with radar, it is an exact figure. Assessment can be done exactly even during the rains, as sometimes the rain showers are not all around the vessel.